everybody, and welcome to this webinar. Thanks for joining today. So we're going to be giving a bit of an update about a project that we've been working on here at Carbon Co-op and with various different partners. So we are going to be talking about that a bit. So as we've got on the call a bit of a mixture of people that are either involved in the project but also people that the project might be completely new to. We'll just give a bit of an introduction to put into context what we'll be talking about today. And then we'll go through quickly what we've done in the UK demonstrator for that project so far. So we're very happy to be joined by Christian today. So Christian will be talking about the German energy cooperative Bürgerwerke and also taking us through the use of the technology in that pilot site that has been developed as part of the REScoop VPP project. So there'll be a bit of time at the end as well for any questions that you might have for Christian. So first of all, just to introduce the project itself. So if we go on to the next slide, please, Alex, thank you. So REScoop VPP, it's a Horizon 2020 funded project. And there are 12 project partners, and here at Carbon Co-op we are both a development partner and we're also a demonstrator partner. So we've been working with various different partners to develop the technology which is being used to test various different flexibility use cases, and there are 5 different pilot sites across Europe. So we are the UK pilot, and there are also pilot sites in Germany, Belgium, France and Spain. And we're all testing the flexible use of electricity. So what exactly is REScoop VPP? So VPP is a term you might have heard before, and this stands for Virtual Power Plant. So the ultimate goal of this project is to create a community-driven virtual power plant, which is providing flexibility services and contributing to a share of renewable energy sources into the grid. So the term virtual power plant, that refers to decentralized power generation. So just to put it into context, that could be a house with solar PV on its roof. That's taking away that requirement for power generation, potentially by fossil fuel powered power plants in the electricity grid. So it's that first point of decentralizing that power generation. But a virtual power plant can also involve flexible power consumers. So how do we use electricity better at times when it's most abundant on the grid and when it's greenest? So they are the key goals of our project, to try and reduce these domestic carbon emissions. So how are we doing this? So we have developed as part of this project the COFYbox. Now this stands for Community Flexibility Box, and in the UK pilot this is also known as the HEMS, the Home Energy Management System. So this can be connected with various different energy smart appliances, whether that's electric vehicle chargers, heat pumps, battery storage, solar PV, immersion heaters. And our goal and our dream is that this is a device agnostic system. So how do we make it accessible for anybody, no matter what brand of EV charger you have? However, as Christian might allude to later as well, this can present some challenges. Not all device brands are open and available to connect with different devices in the home. So that can lead to using various different platforms. But our dream is to kind of unify that flexibility, usage and better optimization of devices so that we can use electricity smartly. So just to very quickly put into context what we've done in the UK demonstrator. So this project started a few years ago, but now we're in the midst of the demonstrator currently. So we have 50 participants who have COFYboxes, HEMS devices installed in their homes. And we're incredibly grateful and lucky to have these amazing participants because they've helped us so much with all of our testing as we've tried to extend the usage of the COFYbox to integrate more devices, different types of devices. So we are really lucky to have our amazing participants, and also a big shout out to our Carbon Co-op team as well, who are pictured below. So some of the team here you might recognise. So thanks to our team, we've been able to connect EV chargers, immersion heaters and battery storage in the UK pilot. And again, there have been challenges, COVID not to mention one, and we've also had chip shortages, long delays with the electricians, but thanks to the perseverance of the team, we've now completed those installs. So we've also got some solar PV connected as well. So over the winter, what we've done is we've been testing turn down events. So this means that the COFYbox is automatically and remotely controlling these energy smart appliances. So a signal is sent through to the COFYbox from the PowerShaper Flex platform. This then responds to when there's times in the day when there's really high demand. So it might be that there's a specific event on TV when the network operator will know that everybody's going to be at home watching TV, potentially cooking, putting the kettle on. So this is when there's really high strain on the grid. So by doing these automated turn downs of these high load appliances, our PowerShaper Flex community are able to then contribute to good operation of the grid. Similarly, we can respond to when times there is short supply. So there might have been a really still day and there's not enough wind generation. So over the course of this trial, we've been testing these turn down events. So since January, there have been 8 turn downs tested with the participants, and that has equated to a 35 kilowatt hour supply of flexibility. So what exactly does this mean? So if we look at the graph on the right hand side, we use smart meter data here in the UK pilot to generate a baseline of electricity usage. So this is from consented meters. So meters that have been connected to the PowerShaper service. And we're able to say that me on a Tuesday afternoon or a Tuesday evening, I use X amount of electricity. So what we're able to do then is we can then quantify how much flexibility is provided by turning down certain devices at certain times. So just to put this kind of total into context, and we've got some figures that have been taken from carbonfootprint.com. This can equate to running 33 dishwasher cycles, that's on a 55-degree cycle, 318 kettles, boiling a litre of water, 49 electric hobs. So that can put into context a bit more. Of course, there's differences and variations, but these are average figures. So that's hopefully to give a bit of an example of the automation testing we've done. And finally, just before I hand over to Christian, I just wanted to showcase some of the brilliant dashboards that our participants and PowerShaper Flex users have been showing and using as part of this trial. So the COFYbox also allows access to an energy monitoring application. So it's based on Home Assistant, which is an open source tool for monitoring energy usage in the home. So this has been adapted to be used with the COFYbox. So over the summer months, our next plans are to test in particular self-consumption optimization. So how do we use that kind of solar generation from those users that might have PV in their homes? How do we optimize their energy usage? And how do we kind of monitor how carbon intensive the grid is so that we can think about when we're using that power. So that's a really brief update of what we've done in the UK so far and a bit of an overview of the project. So hopefully that puts into context a bit what Christian will be talking about, as well as talking about the German Energy Cooperative as well. So I'll hand over to Christian now.
So yeah, my name is Christian Weingärtner. I'm from the Bürgerwerke, and I would like to present you 3 different topics today. Yeah, could you make the next slide and the next one? So first, I wanted to share a few things about us as Bürgerwerke, who we are and what we are doing, and what our mission actually is. And then after that short introduction, I'm giving a few examples about the pilots we have here in Germany, because they are quite different to like a normal private household. We have like bigger pilot sites for that project. And then after that, I'm going to show and present a few learnings we had already. Many things which didn't turn out the way we liked it, but also some quite interesting findings. Yeah, until now, because project's still running, but yeah. Bürgerwerke, we are an umbrella organization or a cooperative with around 110 energy cooperatives who are in our organization, and we are providing different services for our member cooperatives. Yeah, so can you make the next slide? So we have in our network around 110 energy cooperatives and around 50,000 customers, and the local energy cooperatives, they've built and operate more than 1,000 renewable energy plants and around 300 megawatts of capacity. So quite a lot of energy knowledge and energy power plants in our organization, sub-organization. Yeah, but what exactly are we doing? So actually, there are 2 things what our main business is about. The local energy cooperatives, as you can see here on the left side, they build and they operate the power plants, PV plants, wind power, hydropower, and they produce energy and sell it to us as the umbrella organization. And we then sell the energy to customers. And that's and it needed us because for a local energy cooperative who mainly have a few half-time employees or just run early, they don't have the capacity to buy and sell energy and to sell it to customers. In Germany, it comes with lots of administration and accounting businesses. That's why it needed an umbrella organization or umbrella cooperative who can fulfill those services for all local energy cooperatives. Next slide, please. Yeah, and then there's the way of the money, the flow of the money. We, of course, the customers, they pay money for the energy we sell, we provide. Pay our local energy cooperatives in 2 different ways. One, of course, for the amount of energy we bought from them, and secondly, they also get a little bit of the margin we make with energy sales to the customers. And these amounts are then going directly back to new projects building new power plants, renewable power plants. Yeah, next slide, please. And what I just described on the last 2 slides is basically our main mission, or the mission where we're totally excited about, that we can offer everybody in Germany the possibility to supply themselves with energy. And what I mean by that is you can see it here in the chart. I couldn't translate it because it was a picture. But what you can see here is that in the top, what's called energy bürger, they can invest money into a cooperative. So the cooperative can use that money to build PV plants, to build wind power plants, and with that energy, what is produced there, you can, we are buying and selling back to the citizens who initially invested the money. So in that way, it's like a circle economy, and it's quite nice that everybody can own a piece of a PV power plant or a wind turbine and can also consume the electricity from that power plant. Yeah. And that was our main, we always have been doing, but the last few years there's been many other services coming along. Everything mainly because some kind of cooperative wanted to do something, and we started. For example, one very popular business area is that we are building charging networks. So we have one cooperative who's in charge of building charging networks all over Germany, and we also, for example, do project development of large PV systems. So in Germany, for example, it's quite difficult to get a land or a roof where you can build PV on, because there's so many people interested in that. If any local energy cooperative has something like that, then they ask us if we can support them with project development. So there are many different aspects of the work we're doing. Yeah, next slide, please. Yeah, at the moment we are around 30 people. So this one is 1.5 years back, the picture. And yeah, still a growing company. Okay, that was a short introduction about the Bürgerwerke. Now I'm going to show you a few projects, a few pilot sites that we originally chose for the REScoop VPP project, and then I'll show you the pilot sites where we actually landed after some try and error errors with the first round of pilot sites. So our main goal when we chose the pilots has been that we wanted to add value to our cooperatives. And this is quite tricky because there are always many stakeholders involved in those projects and on those pilot sites. First is that the solar power plant is owned and operated by the cooperative, but then there's always someone who owns the house, the building, the company, where the PV is built on, which is mainly the owner, or it's maybe 50 owners in the house. And then next to that owner, there's always, or sometimes there's someone who uses that building, or like the tenants, or the rental, the person who rents the houses for his businesses. So it's many stakeholders involved, and we wanted to add value to that, where the easiest way is that we increase the self-consumption of the PV, the produced PV power, and that's why the reason why self-consumption optimization is the biggest goal of us is because the cooperatives, they can sell energy very easily to the people who live on that same building, who use the energy locally. The moment you don't enter the public grid, it's quite easy to sell energy to inside that building, and that's where it comes from the project. The moment the energy enters the public grid, we are buying that energy and we sell it to our customers, but there's not so much margin involved in that. So the moment we can increase self-consumption inside the building, it's a big impact for the owners, for the users, and for the cooperative. Yeah, that's why this was our main goal. And the second two goals have been hybrid heat systems, because they use a lot of energy, and providing a nice energy monitoring dashboard so that the user or the tenants or the owner can actually see how much energy is used and how much energy is consumed. Yeah, this, for example, was one of our first pilot sites. So, multi-family house with 50 families living inside. But what you can see here is a big PV plant, but what you cannot see is below that building is like a 2-3 meter thick gravel layer where they put a huge heat pump inside. And you can jump to the next slide, please. You see here the heat pump where the pipes come out of the cradle. So this heat pump is like immense in its dimensions, and it's cooling the house in the summer and sending heat for 50 households. We've been talking a lot with the 50 owners of that building, with the manufacturer of the heat pump, and trying to figure out a way how the COFYbox could actually enter the heat pump software. But in the end, we had to cancel that pilot site because it was just way too complex to interact here with that heat pump, and also too risky for 50 households not having maybe some heat in the winter time. Next slide, please. Then this was another pilot site, a big car dealing shop with a huge PV plant, more than 150 kilowatt, I think. And this one also is one of the biggest PV car dealing places in that region. Next slide. And he has, like, because so many EVs, electric cars are coming to his place and getting sold. He has like a few of these hypercharger wall boxes, which also have a battery inside, and would be the ideal asset to improve self-consumption optimization. But here we found, after many meetings with the manufacturer and the owner of the car dealing shop, that the COFYbox is probably not the right tool to operate and to control and steer these kind of pipes in that context. Yeah, next slide. So just this one was another bus station with more than 180 kilowatt peak solar power and few electric buses. Also perfect spot for electricity flexibility, but we found that the COFYbox is just the right assets to control an electric bus or to do big place. So in the end, we can go to the next slide. In the end, we settled to pilot sites which are still a little bit bigger in nature, so no normal family homes, but which have assets you can operate much more easier than those you just saw, because we found that the moment you have a heat pump, which is like not a normal private family heat pump, or you have a battery which is from a special company, accessing that software and trying to manipulate the software in such a way that you can externally send signals to that device is just super complicated, and which wasn't just possible during that project to develop for each pilot site, for each asset, for each device, a different software connection. That's why in the end we have here in the table different pilot sites, multi-family home, normal batteries and normal EV chargers, as well as smaller SME buildings, which also have like normal, I would say, private household assets like batteries and EV chargers. And so, yeah. Next. So that's, for example, another multi-family home, and it has also still PV plant, but it's easier to integrate because the EV chargers, which have just been normal public EV chargers, and the battery is also just a battery which has been sold 1,000 times, and that's why it's quite easy for a home assistant and those products who already have an API interface. Yeah, next slide, please. And what we also found with our pilot sites is that since it's always complicated and still the assets are always unique, we needed lots of electrician work, sometimes to install additional Wi-Fi repeaters so we can actually connect devices to the internet which haven't been connected yet. We always had to turn on electricity to install some plugs for measuring electricity, so which meant like turning off electricity for 50 households is also quite a big challenge. And so monitoring bigger pilot sites we found needs lots of effort, and at the moment we are a little bit skeptical if that really is paying out in the end, because we cannot operate the big heat pump what you just saw, or like electric buses are easier to connect to. And that's still the question if that's reasonable from the effort we have to put in to connect all the devices on place. Next slide. Okay, but anyway, I will show you a few things we learned so far, and we optimized in those places, just to give you an impression of what's possible and what we are just about to, what we're doing. So first always was to bring all the necessary data from different PV plants on the roofs, from the EV chargers, batteries, to one single app like the COFYbox or Home Assistant app. And that meant in our cases that we needed to code many automations and integrations in order to bring all the data in the same way to one dashboard. Next slide, please. So here you see what looks pretty simple actually for a private household to bring PV production and grid consumption to one dashboard. It's quite complicated if you have a bigger pilot site with more than one meter with few different PV plants. It's quite a challenge in the end. But what we found is once we gave the owner or tenants the dashboard, and they got some insight about what the consumption is, or when they consume or when they produce energy, we found that they've been dealing with the energy much differently afterwards, because they understood when the sun is up, there's an immense amount of energy, and if it's getting darker, then they just got another way of handling and understanding how energy works in their home. It was quite interesting to see. Next slide. So, for example, here we have this is one of our multifamily homes. We have like 10 washing machines next to each other. Very old washing machines though. So we did 2 washing machines connected to such a shelly here on the left side, and we scripted a little automation, which did a very simple process. So you had to fill in the washing machine, press on start button in the washing machine, and then you had to actually press here on the shelly on the off button, and then the script would knew that you now want to wash with only PV power. And it started the washing machine once the PV power is high enough, and it stopped it again once it's low enough. So it works quite well, but I would say I have the same automation at home, but it's quite a big hassle washing like this all the time, and you never know when the washing machine is finished. So I don't know if that's the best way to go for it, but it's quite interesting what is possible with that system to do. And if you have time washing your clothes, then I think it's a nice way of starting and stopping washing. Yeah, here, for example, it's a bigger carpenter shop. He has like a huge air compressor and air dryer. It's like a heater which heats the air and dries the air all day long. And what we are trying to do here is that we wanted to only start that power-intensive air dryer when some machinery is used and when the sun is up. So it was kind of complex in the end to do that automation, but it's working now, and it saves quite an amount of money, quite amount of energy, because it now only turns the air dryer on when some machine is in, and it doesn't run all day long. So also hasn't been a struggle to figure out all the necessary parameters. So it works smoothly, but once it's installed, it's the optimization. Next slide, please. Yeah, this is one example. We tried after the bigger heat pumps didn't work. We just tried to optimize normal air conditioners, and I have to say this was actually pretty easy to do, because most air conditioners have like an online app, or you have a smartphone app, and you can connect those air conditioners easily to the COFYbox or to Home Assistant platform. And what you get then on your dashboard is like the left, what you see here on the left side. You get a simple dashboard with where you can see the temperature, and you can also stop the heat pump or the air conditioner. And this is actually an air conditioner which can cool and heat not at the same time, but it can either cool or heat. And it's pretty easy to do. This one actually worked within a few seconds. Just like add the air conditioner to Home Assistant, and then you can stop it automatically with connected to the TV. So it's quite a nice feature what we installed here. Next slide, please. Yeah, this one was also quite easy to install and to optimize. This is I don't know if you have something like this in UK. It's quite expensive water tap, which basically does normal hot and cold water, but it can also provide water with gas, and it can also do cooking, boiling hot water. So when you press here on that button, you can directly cook a soup or a tea under that water tap. Just see the question with the washing machine. Yeah, it just interrupts and then it resumes later. But the washing machines, only the old washing machines are capable of that. I don't know about the newer washing machines. For the question from Peter. I just want to say the water boiler, basically we just plug the Shelly inside and also connect the Shelly to the PV plant. Claire, can you make one slide back? Yeah, here for the water boiler, there was also very simple integration and useful one. We just plug the Shelly inside and connect it to the PV power, and always switch the Shelly off now whenever there's not enough. And since that cooker has like this little water tank which always stores boiling hot water, it's nice. You can use it basically as a water battery. You save the PV power inside that tank, and whenever there's no PV, you just turn it off. So it works quite well and quite easy integration. And I think in Germany we don't have many households who heat up the water with electricity. But whatever water boiler you have, I think this is a quite useful and very easy to install implementation for self-optimization. Yeah, slide. And then here, for example, I think you know COFYbox, it's an English brand. We also have it in Germany. It's quite popular here as well. But we found once you have that Zappi and you have a battery from another brand, it's getting quite complicated to make a PV optimization when two devices are directly connected to the PV plant and trying to optimize the system. What was the question, Peter? Sorry, I couldn't read all the messages.
Yeah, just the device that you mentioned in the last slide with the for the cooking.
The cooker, but it costs. It's called cooker. You see it on that. It's called cooker actually.
Oh, okay, that's what it's called.
Quite expensive. It costs around 3,000 euros, I think. It's quite expensive for a water boiler. But it's just a premium product. You basically have nothing more on your kitchen, just that water makes everything. Boiled water, water with gas, and filtered water, and whatever you can imagine in one machine. Yeah, that was basically everything I wanted to present. Do you have any questions?